for Session 3. Session 3 will cover the following content. Learning Outcome 2.4.3b. Use the chain rule for differentiation. Students will encounter functions that can't be differentiated using the basic rules. In these cases, we need to examine the function to see if we can break it down into other functions. This gives rise to three very important rules in differentiation: the chain rule, the product rule, and the quotient rule. Learning Outcome 2.4.3b. Use the chain rule for differentiation. Work in groups to do this activity on the chain rule in differentiation. Number 1. How do you teach the chain rule? Number 2. Choose one group member to teach the chain rule to the rest of your group as if they were new to the concept. Use the example, find the derivative of y equals 2x plus 1 cubed. Number 3. Give feedback to the chosen lecturer. Number 4. Discuss any issues that you face teaching the chain rule in class. Our 8 basic differentiation rules are limited because they cannot be applied to functions of functions, also called composite functions. We use the chain rule to find the derivative of 2 or more composite functions. The chain rule is new to students in Level 4 and it's a problem area for many. Let's start off by looking at what a composite function is. In other words, how do we identify functions of functions? Here is a list of functions: e to the power x, natural log or ln x, sin x, cos x, tan x. Anytime we touch the x of a function, we have a function of a function. For example, e to the negative x, ln 2x, sin 3x, cos x squared, tan of negative x. So x to the power of n is a function. X to the power of n plus a is also a function, but if we take the square root of x to the n plus a, or we raise it to a power p that we cannot simplify, or we don't want to multiply out in full, we have functions of functions. Looking at a more specific example, for y equals x cubed, y is a function of x. But for y equals 2x plus 1 cubed, y is a function of a function or a composite function. To differentiate functions of functions, we need new formulae. The chain rule allows us to extend the basic rules to include composite functions. The chain rule states that if we have a function y equals f of u, where u is another function g of x, then the derivative of y is the derivative of y with respect to u multiplied by the derivative of u with respect to x. You can see from this formula why it is called the chain rule. It can be helpful to show students how both sides of the equation are equal. This formula can be found on the Paper 1 formula sheet. To apply the chain rule, follow these steps. First, identify the two different functions, an inner function and an outer function. Second, let the inner function equal u. Third, differentiate u and y to find du dx and dy du. Substitute these into the chain rule formula. And lastly, substitute the original function for the variable u and simplify to get the final answer. There can be more than 2 functions, and you may need to apply these steps several times over. This simply means that our chain becomes longer. Let's take a look at this being applied in an example. Remember our composite function y equals 2x plus 1 cubed. We will differentiate it using the chain rule. First, we let 2x plus 1 equal u, which means that y equals u to the power of 3. Next, we differentiate u, and we find that it is equal to 2. And we differentiate y, and we find that it is equal to 3u squared. Then we substitute these values into the chain rule formula, which gives us 3u squared times 2. In the next step, we substitute u back into our equation. This gives us 3 multiplied into 2x plus 1 squared multiplied by 2. Finally, we simplify to find the final answer. Let's watch some more examples worked out by lecturers using the chain rule.
Differentiate y using the chain rule. Given that y is equal to square root of 13x squared minus 5x plus 8. All of those are under the square root. Now, with the chain rule, there's one aspect we have to understand. dy, derivative of y, with respect to x is equal to the derivative of y with respect to u multiplied by the derivative of u with respect to x, which makes it necessary for us to begin with the following. So we must assign some variables. So we're going to let 13x squared minus 5x plus 8 be equal to u. Then you're going to differentiate y with respect to u. So what does it mean then? It means that dy du is going to be equal to u to the power 1 over 2. We know that this is inside the root sign. So what does it mean? It means that bring the power down, 1 over 2 u, take 1 from the power, 1 minus 1 over 2 is equal to minus 1 over 2. This is dy du. Then, what is the value of du dx? So this is u. So du dx then, du, the derivative of u with respect to x, is going to be equal to, so you're going to be writing it backwards now. So you'll be differentiating this function of u with respect to x. So differentiate 2 times 13, 26. So 26x minus 5. That's the du dx. Once we have that, then we can put our solution right here. Dy dx is equal to, what is dy du? Dy du is equal to 1 over 2 u to the power minus 1 over 2 multiplied by du dx. Du dx is 26x minus 5. But we know that u, so you must substitute u now. We know that u is equal to 13x squared minus 5x plus 8, which makes it 1 over 2, open bracket, 13x squared minus 5x plus 8, close bracket, all to the power minus 1 over 2, multiplied by 26x minus 5. Finally, we cannot stay with the power of a negative, which then makes it 1 all over 2, this 2. This whole thing, since it's to the power of negative 2, it's going to come a denominator of 13x squared minus 5x plus 8, close bracket, to the power of 1 over 2, multiplied by 26x minus 5. And this could be our last step. 2 square root of 13x squared minus 5x plus 8. This one is the numerator of this times 1 becomes 26x minus 5. This is your final answer.
differentiate with respect to x. The function of x is equal to sine 2x. Take note, this trig ratio sine consists of two parts. It consists of the ratio, which is sine, and it consists of the angle part, which is 2x. In other words, in order to find the derivative here, we need to get the derivative of the angle multiply the derivative of the ratio, where you only consider the ratio. Now, there are two ways of doing this. If I want to apply U substitution here, then it's advisable to change the function of x to y. So I'm going to say y is equal to sine 2x. Then I'm going to start with a statement. And I'm going to let my angle, always in the case of trigonometric ratios, your angle will be equal to u. In other words, now I'm going to say, if u is equal to 2x, that implies that y will now be equal to sine of u, because u is 2x. Now let's find du dx. Du dx, I find the derivative with respect to x because u is expressed as a function of x. It's going to be 2. Same procedure, formula number 5, x 1 minus 1. And that is equal to 2 x to the power 0, which will be equal to 2. Because anything to the power 0 is equal to 1. Obviously here, dy, du, and I go straight to formula number 14. The derivative of sine is cos u. Now I'm going to find dy dx, which will be equal to dy du multiply by du dx. You can see there du and du cancel out, you get dy dx. What is dy du? That's going to be equal to cos u. What is du dx? That's going to be equal to 2. And you have a nice answer of 2 cos u. But what is u in terms of x? U is equal to 2x. So you just back substitute u with 2x. And your final answer is 2 cos 2x. Let's look at B. The first example was a trig ratio where u was the angle. It's important to note for trigonometric ratios, if the angle is not 1x, then u will be equal to that angle. Now we move to a exponential expression, e to the power minus x. Now if you look on your formula sheet, people, then you can see there formula number 13. If y is equal to ekx, then dy dx will be kekx. In other words, I can apply that formula and I can substitute it directly in here, which I will use as my first approach. Dy dx will be equal to, if you look there, k is the coefficient of x. What is the coefficient of x here? The coefficient of x here is minus 1. That's k. And then e minus x. That is, you can read this one directly from your formula sheet. In other words, in the case of exponential, based on formula number 13, just identify k and then write down the equivalent straight away from your formula sheet. Or, like I say, you can also use U substitution. Now let's look at U substitution. Y is equal, and then we can test whether that answer is correct. E to the minus x. Very important, same. In exponential, your exponent will be u. If u is equal to minus x, that implies that y is equal to eu. So we're going to work out du dx exactly the same as the previous one, which will be equal to minus 1 x minus 1 minus 1, because the exponent is 1. So it's positive 1 minus 1, which will be equal to minus 1 x to the power 0, and that is equal to minus 1. dy du, based on your formula sheet, formula number 12, eu remains eu. Exactly the same now, dy dx must now be equal to du dx multiply with dy du. And then you will see that is du dx minus 1, and then eu, which will be equal to minus 1 e to the power u. And then you just back substitute what u was. U was equal to minus x. So it's going to be minus 1 e to the minus x. And very interesting, people, the formula that I've used here as well as there, it's formula number 10. That is when you're applying the chain rule with the aid of U substitution. So these formulas that I've used here are on your formula sheet, formula number 10. And you can see here clearly that these answers are exactly the same, which makes it very interesting. And it's also nice to see how you can engage with your formula sheet and get exactly the same answer.
Using the chain rule in this way can become quite time-consuming and cumbersome. We can use the chain rule to extend the basic rules of differentiation from earlier, to allow us to differentiate functions of functions directly without applying the long-form U substitution. Once students have got the hang of applying these adapted rules, they shouldn't need to write the chain rule out in the long form, and they can just apply the shortcut rules directly. Let's take a look at these adapted rules. They can all be found on the paper 1 formula sheet. The power rule states that the derivative of f of x to the power of n is n multiplied by f of x to the power of n minus 1, multiplied by the derivative of f of x. The coefficient rule states that the derivative of a coefficient such as a multiplied by f of x to the n is the coefficient multiplied by the derivative of f of x to the power of n. The exponential rule states that the derivative of e to the power f of x is e to the power f of x multiplied by the derivative of the original exponent f of x. The logarithmic rule states that the derivative of the natural log of f of x is the reciprocal of f of x multiplied by the derivative of f of x. The trigonometric rule states that the derivative of sine f of x is cos f of x multiplied by the derivative of f of x. The derivative of cos f of x is negative sine f of x multiplied by the derivative of f of x. And the derivative of tan f of x is sec squared f of x multiplied by the derivative of f of x. This table summarizes the 8 basic differentiation rules, as well as the new rules derived for functions of functions. This table can be found in your workbook. Now try these examples in pairs, applying the differentiation rules directly without using U substitution. Discuss any issues you face teaching this section in class. Here are the solutions.
Differentiate with respect to x. Y is equal to e to the power 2x. This is an exponential expression. Let's look at A. Y is equal to e to the power 2x. If you look at your formula sheet, on your formula sheet you will see the formula, the derivative with respect to x of e kx. And then you will see the answer there is k e kx. Now, can you see this e kx, e 2x? In other words, k is equal to 2. So by using this formula now, I can directly write down the derivative. dy dx is equal to k, which is 2, e k, which is 2x. That's the answer there. I've just applied that formula. Now let's look at B. Y is equal to ln 3x. On my formula sheet, there's also another formula, formula number 11, the derivative with respect to ln kx is equal to k over kx. By looking at this one, you will agree that k is equal to 3. So I can straight away write down the derivative. dy dx is equal to k, which is 3, over k, which is 3x, and your final answer there is 1 over x. Directly using these two formulas in order to solve these two problems. Differentiate with respect to x. A, the function of x is equal to 2 sine 3x. Let's look at A. The function of x is equal to 2 sine 3x. From my previous knowledge, when we've applied U substitution, you will agree that we had the derivative with respect to U of sine. Remember, we've said that our angle was U. It was equal to the derivative of U times the derivative of sine, which is cos U. In other words, what did we do here? It's the derivative of the angle, you can see there, times the derivative of the ratio. And the angle remains unchanged. Very important. You can see there the angle is U, the angle is U. But the derivative of sine, according to my formula sheet, is cos. So here you focus, the first part you focus on the angle. And the second part you keep that angle and you only focus on the ratio, the derivative. Now if you're going to apply that here, that is 2, right? The derivative of this angle, what is the angle here? The angle is 3x. Obviously it's going to be 3. Then you keep that angle as 3x. Can you see what I'm doing? I keep the angle as 3x. What is the derivative of sine? Based on my formula number 14, that is cos. In other words, That's going to be 2 times 3. That's 6 cos 3x. Let's check your answer. My angle is given as 3x. My derivative is also given as 3x. The people made the mistake. They normally change the angle to x when they consult the formula sheet. Please, you got no right to change no angles. You need to get permission from the person that designs the problem. Let's look at B. Y is equal to bracket 4x plus 3 to the power 6. This is a power rule. This is an inside function and an outside function. In other words, you're going to apply this tool here, the derivative of un. What is this? That is the derivative of the base and then the derivative of the power, where it will be n minus 1. In other words, u is 4x plus 3, n is equal to 6. So we need to find the derivative of 4x plus 3. In other words, simple terms, the derivative of the inside function times the power. Can you see when you focus on the power, it becomes exponent, u, exponent reduced by 1. That is the equivalent of the power rule as illustrated on your formula sheet number 5. So what will this be? dy dx. Square bracket, derivative of that inside the bracket, that is 4 plus 0, because the derivative of 3 is 0, and then focusing on the power, exponent, round bracket, that 4x plus 3, then that exponent reduced by 1, and you close. You see I've exactly applied that tool. And now you just simplify it. 4 times 6 is 24. Round bracket, 4x plus 3. And 6 minus 1 is 5. And that is my answer. It's very important. If you know this tool here, you just apply it there. If you know that tool there, you just apply it. But derivative of the inside, derivative of the power, and that gives you that answer. Differentiate with respect to x. Y is equal to sine e2x. Remember, we put in a y there. Let's look at number 8. Y is equal to sine e2x. Now, this is a combination of what we've covered so far. If we look here, the angle here is E2x, which I've illustrated earlier on, and the ratio here is sine. So we're going to apply exactly the same tool as before. The derivative with respect to u of sine u is equal to u derivative, which is the derivative of the angle, and then derivative of sine is cos u. But now we also have the derivative with respect to x of ekx, because that's on your formula sheet, because that represents u there, which is equal to kekx. So that means if we're going to focus first on our angle part, we're going to apply that tool. And then with the top one. So we're going to apply these two tools in order to solve this one. dy dx. The derivative of the angle E2x, which is ekx. What is that? That is k, which is 2, E2x. That is the derivative of my angle part times, remember what I said, my angle remains unchanged because that's the angle. The derivative of sine is cos. And we can just write it now in a nice form. It's 2e 2x cos e 2x. What is nice, people? This is a 3-mark question in the exam. Even if you stop there, 1, 2, and 3. And this gives you your 3 marks. Let's look at the next one. B. Y is equal to E tan squared 2x. Now people, it's very important always when there's a power to write it in standard form. E bracket to the power 2 tan 2x, because I want you people to see the rule. So what tools are we going to use here? The derivative with respect to u of EU, that is the derivative of the exponent, and then obviously EU remains unchanged. But now if you look at the u part here, then the u part looks like this, un, because it's the power, and that is equal to obviously the derivative of u, and then obviously n minus 1. But if you look at the inside part there, then you're going to get something like this, the derivative with respect to u of tan u. So people, this problem is not becoming more difficult, just longer. Please, not more difficult, just longer. That's going to be the derivative of the angle. Can you see the angle remains unchanged, and the derivative of tan is sec squared u. So now, remember, you can either work from outside to inside, or you can work from the base to the power. So you can start with the exponent. As you can see there, the derivative of that u. U is this part, which means u looks like this. The combination of those two. So let's start, do the breakdown. dy dx, just follow my explanations. Right. I'm going to start outside. Inside. Right. The derivative of that angle 2x is 2. I'm applying this tool here. Then the derivative of tan, remember the angle remains unchanged, is sec squared. In other words, I have solved the inside. Angle ratio. Now, I'm going to move to there. What do you get there? We've done that already, Mos. We've solved the inside. Now just the power, because we only focus on the power. So that's going to become 2 bracket tan 2x 2 minus 1. Now I've solved that complete thing there. And then I look at E, which remains unchanged. E, obviously tan squared 2x. And now I can just write it in a nicer form. Remember, you have 2 times 2, that gives you 4. Right? And now you can write the ratios anyway. You can now say, okay, this will give you sec squared 2x. That's going to give you tan 2x. And that's going to give you E tan squared 2x. And this you can even test. 1, 2, 3, 4. Let me show you again. 1, 2, 3, 4. And that gives you 4 marks. Nice if you write it like that. But just you can have the 1 there. 1, 2, 3, 4. and this is a question which is worth 4 marks in the exam.
Teaching tip. Advise students to write out the problem line by line, giving all of the steps to help with their understanding. They need to do lots of practice examples. Once they have a better grasp, they can take shortcuts. And that brings us to the end of Module 4.